Hello, all. Let us talk about some of the basics of embedded system. So, we will initially talk about the definition of embedded system. So, to understand it simply, uh, embedded system can be thought as a simple computing device. While we use the word simple, it is not so simple actually. So the usage of embedded systems starts from some of the basic applications and can extend up to a complex application, like example a robotics kind of thing. So uh, basically, as we mentioned, it is a computing device which can perform many activities and has the capability of a kind of a computer to perform the activities. So the appliances we use in our daily life, whether it be washing machine, microwave oven, smart TV, okay, and then the washing machine, the mobile phone, tab, laptop, everything fall under the embedded system. So to put it simply, an embedded system is which has some intelligence embedded into it and can perform various actions based on the requirements. So mm, the when we say actions being performed, the entire communication internally happens digitally. There are also analog signals which are involved. So we can say that the digital and the analog signals play a crucial role in embedded system. So for the beginners, they need to understand what is an analog signal, what is a digital signal. Analog signal is something which varies continuously over time. Example, if we take something like a temperature where we stand right now, this temperature is not constant, right? Example, it is not constant like 25 or 30 degrees. It could vary by 25.1, 25.2, or whatever. So that continuously varying values, if you represent in terms of waveform, we see that it is continuously varying over a period of time. So that's the graph we get, right? While the analog signal shown here is a sinusoid signal with a fixed time period, in reality, the values which we talked regarding the temperature sensor or any other kind of sensors is not in this form. It will be varying continuously, as we mentioned, and that variation is not in a proper sync. It could be any value at any point of time. It could go to a maximum value at this point of time, and it can go to some minimum value later, and vary between these max and min values. And then while we talk about some of the analog signals, all the processing internally to the in the embedded system happens using the digital signals. So when we say digital signals, it involves zeros and ones. So those are the major things, the binary values which we say, and this uh, zero anyway is a low level, that is understood. High can be different values, right? So high could be 1.8 volt, 2.5 volt, 3.3 volt, 5 volts, sometime plus 12 volts, whatever. So there are several logical levels that are associated with the digital signal. So in embedded system, the sensors that we read are analog in nature. And then there are these digital signals which follow a specific logic levels. Why they have to follow specific logic levels is, if we are communicating between two digital devices A and B, right, they need to have a common voltage level, right? Otherwise they will not be able to talk with each other. we need to perform some other activity in between, so that both of them understands the common voltages. So logic levels which we talk helps us to bring that down that communication gap between the driver and the receiver, and the communication to happen without any issues. If we see in embedded systems, there are several digital logic levels depending on the voltage level. So this is a small list of logic levels. So most of the embedded engineers work with the TTL, CMOS, but if we go further to high-speed designs, we might have ECL, HTL, and then LV CMOS, LV TTL, the low voltage CMOS, low voltage TTL. So we will talk about in detail about these logical levels in the advanced series. In this, we are just giving you a pointer to kind of logic levels that could be there. And then, as we mentioned, mainly these logic levels are used to uh, bring sync between the driver and the receiver, whether it be from the voltage levels or the internal circuits that are involved may have different characteristics, like the propagation delays that are associated with the circuits, and then speed at which they can turn on and off the internal circuits, right? So these ultimately all these logic levels are realized by some logical gates internally. So all these different parameters that are associated with these are very important for us to understand. So this also on why the speed varies, why there is a propagation delay, all these we will talk about in the advanced level. As this is a basic level, we will just go through on what are all the different things. And then these embedded systems can be used in different domains. Like example, medical, all the automated systems that we see in medical domain in our hospitals are all embedded things. And we see that there are lot of applications on wireless also coming up in the modern days. And then industrial, telecom, consumer, military, networking, manufacturing, aerospace, all these. These are just few of them. There are several other domains which are there where embedded systems are used. So hope we gave an introduction of what is embedded systems and where it is used and what are all the signals that are there in embedded systems. We will talk about embedded system architecture and other details in the next video. Thank you.